Hello everyone, my name is Tony Record and I'm an AP Calculus teacher at Avon High School in Avon, Indiana. And in this video, we're going to take a very detailed look at the 2022 Operational AP Calculus BC exam, and particularly at question BC number 2. So without further ado, let's take a look at the question. The question read, a particle is moving along a curve in the xy plane and it's at position x of t, y of t at time t greater than 0. The particle moves in such a way that dx dt, the derivative of x with respect to t, is the square root of 1 plus t squared, and the derivative of y with respect to t is the natural log of 2 plus t squared. At time t equal 4, the particle is at the point 1, 5. And part A presented the students with the directive to find the slope of the line tangent to the path of the particle at time t equal 4. So it's a very traditional BC particle motion beginning free response type question here. And the very first part here is only worth 1 point. And it's pretty cut and dry how this would be scored. So the skill that's being tested is obviously the student's understanding of the fact that we have to take the derivative of y with respect to x to get the actual slope in the xy plane, and the fact that we're going to have to find a ratio of our derivative of y and our derivative of x. And so an exemplary response would look something like this, that proceeds to find the answer of 0.701 rounded to 3 decimal places. And of course, a student would never have to use extra language right here to say that the slope of the tangent line was equivalent. They don't have to pronounce that formal declaration of their answer. Pretty much everything in that first line would be absolutely great. Now, there are some scoring notes I want to kind of emphasize here, just a couple. And first of all, in order to earn this single point, the setup used to perform the calculation has got to be evident in that response. So in other words, we need to see some kind of mechanic that allowed the students to arrive at that answer. Now that mechanic could be as formal as saying y prime of 4 over x prime of 4 is the 0.701. That's fantastic. But if a student didn't declare the y prime and the x prime, went straight to a non-simplified quotient, like the natural log of 2 plus 4 squared over the square root of 1 plus 4 squared, that would be enough to earn that single point. Or a slightly simplified version, natural log of 18 over square root of 17, would be enough to show that quotient that would inevitably lead to our decimal approximation of 0.701. So any of those three things is perfectly acceptable. Now, let's take note. A response with an incorrect equation of the form function equals constant. Now, what do I mean by that? Well, let's say the student knew that we had to take the derivative of y and we had to take the derivative of x and divide them in that order, but they didn't communicate, especially at the t value of 4. So as you can see right here, y prime of t over x prime of t equaling a correct unsimplified answer. That will not earn the point. Now, such a response, though, is going to be eligible to earn any additional points for subsequent parts, as you're going to later see. We just don't like that communication. The student just didn't quite understand that this was a very specific time when we wanted to find that tangent. All right, let's move on to part B now. Part B asks the student to find the speed of the particle at time t equal 4, and then to find the acceleration vector of the particle at time t equal 4. So one of the things as teachers that we want to make sure that we do, and students for sure, understand that even though this is a single part question, it is asking you to find two different things. So first of all, let's take a look at the exemplary scoring rubric. And this is a problem that is worth 3 points, quite a bit going on here. And so for the speed, we see that we want the student to know that we're taking the square root of the sum of the squares of the derivatives of our x and our y evaluated at 4. Like I said, a lot going on there. And so once that is assembled, whether it's simplified or not, right? The unsimplified version would look something like that. And a simplified version could be like 5.035 rounded to 3 decimal places. That would be a perfect example of scoring the point for the speed. Now for the acceleration, the student would have to go ahead and take the derivative of both the x and the y. Now notice the student didn't have to do that in part, the beginning part of this question, because the derivatives were already taken. But we have to find x double prime and y double prime in order to find the acceleration. And of course, evaluate each at t equal 4. And so an unsimplified vector form could look a little bit like this, or a decimal approximation would look something like this. Again, we would look to the first 3 decimal places. And that would be an exemplary response that would earn the 2 points awarded for the acceleration vector. Once again, a student doesn't have to declare their answer like we've seen in both of these portions. Okay, now, probably a lot of questions on your mind, like, well, what if this happened? What if that happened? Well, hopefully the scoring notes will take care of many of those questions. So, first scoring note. In order to earn any of these 3 points, the setup used to perform these calculations have got to be evident somewhere in that response. So the following examples would be perfectly fine to earn the first point. Say the student actually wrote the square root of the sum of the squares of the derivatives evaluated at 4. Well, that's exactly what we're testing. So if the student goes straight from here to an answer point, to their decimal value or an unsimplified value, that would be perfectly acceptable. Now, as far as the acceleration, we would take just simply the x double prime comma y double prime presented in some kind of a vector environment, and that would be allowed to earn both the second and the third points. Okay? We'll talk a little bit about the notation of the vector environment in just a moment. So the second and third points, obviously they can be earned independently, right? They're 2 pretty much separate things in terms of finding the x component and finding the y component. Next, if the acceleration vector is not presented as an ordered pair, the x and y components must be labeled. So oftentimes students may not use the vector bracket notation, right? The angular brackets. We're going to go ahead and at the reading understand that in context the student is referring to a vector, and so using parentheses as their grouping symbols around that particular pairing is going to be acceptable, right? We understand it's going to be a vector. Maybe it's not the best way to communicate it, and as teachers we can always implore our students to try to use proper vector notation, but we're going to overlook that on the AP exam. Now, as I said before, if the x and the y are not in some kind of a pairing with some kind of grouping symbols around the outside, they have to be labeled. And if the components of the acceleration vector are reversed, then that response is not going to earn either of those last 2 points. We feel that's just a little bit too egregious and the student's not quite grasping the understanding of who is the x and who is the y here in that particular case. All right, and then a response which correctly calculates expressions for both x double prime and y double prime. So the student, went through the process of actually finding those. Maybe they did those by hand. Maybe they had some kind of a CAS calculator that assisted them. But then they failed to actually evaluate at t equal 4. We're going to go ahead and sort of go off script here, and we're going to award 1 of the last 2 points. We see that the student understands that acceleration is going to be the derivative of those 2 first derivative components. It's just that we didn't carry out that evaluation. So 1 of 2 points could be earned there. And an unsupported acceleration vector. Well, let's say that a student actually has the correct value. Maybe they wrote it simplified, maybe they wrote it unsimplified. we're going to go ahead and award one of those last 2 points for a somewhat bald answer of the acceleration vector, knowing that the student did the correct procedure using their calculator most likely. It's just that they didn't communicate that setup like we would want them to do. All right, taking a look at part C now. Find the y coordinate of the particle's position at time t equals 6. Now this portion obviously is going to require a little bit of use of the definite integral and the fundamental theorem of calculus. And so what we're looking here for that y of 6 is to start at our y of 4. We have to use the fact that we have some information about time 4. The particle is at the point 1, 5, so the x coordinate would be 1. The y that we need in this problem is going to be at 5. And then we would just sort of accumulate a little bit more position change there by way of the definite integral of the dy dt expression with respect to t from the lower limit of 4 to the upper limit of 6. And so from this point on, a lot of calculator intervention is going to slip into the problem. But you notice that that first point is going to be awarded for just the integrand. Right, so we'll kind of get to that a little bit more specific here in a moment. But what we're looking for is just the student to show that this natural log of 2 plus t squared, the dy dt expression, has to be integrated. All right, we'll talk about, again, whether it has to have boundaries or not, correct boundaries or not. Now, using y of 4, what does that mean? Well, somehow implementing the fact that the y of 4 is going to be used, it's going to be added to this definite integral in order to find that position. That alone is going to be a point. And then, of course, the actual answer already combined and rounded to 3 places, 11.570 or 11.571 would be our answer point. So we got quite a few scoring notes to run through on this one. So first of all, for that first point, an integrand of the natural log of 2 plus t squared can appear in either an indefinite integral or an incorrect definite integral. In other words, maybe the student presents that in an integral expression without boundaries at all. We're going to be okay with that because we see that the student knew to perform an antiderivative of that dy dt over dt expression to start the wheels turning to get that position. Now, if the student were to put that in an incorrect definite integral, which is pretty much stating incorrect boundaries that would not help us, we're still going to be okay with that because we're just focusing on that integrand only. Now, a definite integral that has the incorrect limits is not going to be eligible for the answer point. They still might be able to get the second point if they've somehow utilized the y of 4 and implemented that correctly, but the answer point will be sacrificed. Similarly, an indefinite integral is not going to be eligible for that answer point. They still could earn, again, that second point utilizing the y of 4. Now, for that second point, the value for y of 4 must be added to a definite integral. Whether it's our definite integral or not, we still need to see that y of 4 being added. Now, a response that reports the correct x coordinate of the particle's position at time t equals 6. So a student would say, oh, x of 6 is our integration of our derivative of y over with respect to t expression from 4 to 6. And that answer, by the way, would be 11.200. So you could look for that particular answer and know right away what they did. We're going to go ahead and allow the students to earn 2 of the 3 points. You know, they really had a pretty good grasp of the concept of finding position given this derivative. It's just that they kind of got their x and y's mixed up at the very beginning with that initial position. So we're going to call that a 2 out of 3. Let's say you have a response that earns the first point, but it doesn't earn the second point. Well, we can still earn that third point only with our correct answer or an answer of 6.57. So in other words, we have the right integrand. The setup is looking pretty good from that standpoint, but the student just did not seem to utilize the y of 4 at all, okay? But they resolved that definite integral correctly. They knew how to enter that into their calculator. Well, if that answer of 6.570 or 6.571 is presented on their paper, we will go ahead and allow the student to earn that third point. We just don't want to jeopardize the student, 2 of these 3 points by just forgetting that initial condition, y of 4 in this case. And if the differential is missing, this always comes up from time to time. Teachers and students will ask, well, what if a student forgets the little dx or in this case, the little dt? So often it's a very forgivable offense. But in problems like this, it's got a little bit more, I don't know, there's a little bit more strictness, I should say, in whether that dt is going to be present. So here's what you want to look for. If a student is finding the y of 6 value and they present the definite integral, they know that they're going to earn the first point, okay? That is not presenting the y of 4 the way that we want them to, but we're still going to allow them to earn that third point if they resolve the integral correctly, whether they introduce the y of 4 eventually, or if they just typed this into their calculator and got a correct answer, as I mentioned before. Now, that's a dt that's missing that, well, we can kind of overlook. However, if they were to add the y of 4, we love the kid that does this, but we're not real happy with the fact that they added the y of 4 after the integral. So we're not quite sure, are they having this y of 4 value involved in this integration anti-differentiation process or not? Well, a setup like that will not earn the first point. Now, it is eligible for the second and the third points, and I would say that the second point is a give me on this one because they have the y of 4 there. And if they resolve this answer correctly to get our correct answer, right, the 11.570 or the 11.571, we're going to be okay to award that third point, but they've only lost that first one. And then the third variation of the differential that's missing is the student that puts the y of 4 in front, okay, much better place for it, but forgets that differential at the end. We're going to say that the student would still earn those first 2 points. It's okay the differential is missing there. And of course, the student would be eligible for the third point with a correct answer. Hopefully that helps a little bit with that part C. Now with our part D here, the question is to find the total distance the particle travels along the curve from time t equal 4 to t equal 6, a very common question that a student is likely to encounter on the BC particle motion free response question from year to year. And so this particular problem is worth 2 points, and the first point is awarded for a correct integrand. And so we see that the student needs to set up an antiderivative taking essentially the antiderivative of speed, if you remember from before, the square root of the sum of the squares of our 2 derivative expressions. Now the correct boundaries would in this case be 4 to 6, those were provided, and a little bit of calculator magic will provide an answer of 12.136. So the scoring notes on this, not too many of them. Basically, the first point is going to be earned for presenting the correct integrand, but it's got to be in a definite integral. I don't see how a student would likely miss those limits of integration since they were provided in the question, but it could happen. But we're still going to go ahead and award the student the first point as long as they have that integrand. Now, they may have just used the dx over dt and the dy over dt symbolic notation like you see here in the slide, or they may have replaced it with the actual expressions. Either way would be acceptable to earn that point. And then to earn the second point, the response must have earned the first point, and it must present that value of 12.136. Right? We can't just award that bald answer of 12.136 any credit there. And an unsupported answer, as I said before, is not going to be very valuable on the part of the student. We need to see where that thing is particularly coming from. All right. So I think part D is, even though it is the last part of the problem, might be one of the easier parts here, aside from maybe part A to score. And I always like to give a little bit of data on the problem. From 2022, the mean score of this particular question was a 5.22, which isn't too bad. As far as a BC exam goes, anytime you get an average into the fives, that's usually a pretty good performance. So hopefully this takes care of any questions that you might have, whether you're a teacher or a student, in trying to score the 2022 BC2 operational exam particle motion problem. Until next time, thanks for watching.